Number 1 is C.
Yeah, C.
Alright, very good. Who's got number 2? Alright, Lou.
Use price constant 626 times 10 to the 34 to solve the problem. D.
That is correct. Anybody got number 3? Now these are points for your bell work final grading period. Go ahead, Rain.
Which is the most probable location for an electron in this orbital? I got A.
3 is C. 4, we'll go over anything you don't understand after we go through all of them. Alright, Lou.
The principal of the final number indicates what population of electron. C.
That is correct. And number 5. You got number 5. You get some points. Simon?
What number?
5.
I got D.
Well, read it for us. You got the right answer.
Of the elements PT, P, Li, and Kr, which is a non-metal.
Very good. And number 6. All right, Lou. Earlier in the year, we were reviewing significant figures. We counted the number of paper clips in the box, and there's no decimal there, so there's approximately 100 in there, or anywhere from 50 to 150 paper clips in the box. Now, if you look at this sheet that we gave you, the first set, the first question, says how many significant figures are in 0.02. So there's 1 there. Check yourself. Number 2, how many do you see there? Raise your hand. There's 2 there. The 2 and the 0 are true. How about number 3? There are 3. Very good. So the electron dot structure for water, you have the hydrogens that have 1 electron, and you have the oxygen has 6. The red, 1, 2, 3, 4, 5, 6 would be the oxygen. 6 valence for oxygen. And what happens, the hydrogen is going to share these with the oxygen. You'll see that right here. So if I draw a circle around this, you'll see how many electrons there. Yeah, there's actually 8, right? And if you look around the hydrogen, you're going to see there's 2. And that behaves like helium, right? So water has this kind of a bent structure. These lone pair electrons will push the hydrogens to the side, and then these kind of repel each other. So it has this kind of a bent structure where you see like this. They call it bent. That is the angle. Will pair up. They will not group up like this. So we're looking at a silver bromide for our second problem, right? And you'll notice here that if they did this, you would have destructive or constructive interference. Like if I'm talking and you're talking, that would be destructive. You can't hear. So what would happen here? These would end up, 2 of these are going to end up going in the same direction, and what'll happen? They'll form a bigger wave. That's a problem. So that's why you're not going to see 3. So the silver has 1 electron, or it can have 2, or it can have 3. Under this conditions, we just see 1. The lab yesterday, we just saw 1. So I'm going over one of the answers in the lab yesterday, the second one. So you had bromide, and it has 7 around it. This is the electron dot structure for silver bromide, and the formula would be AgBr, right? You'll see another important thing to note here is that the electrons always surround the nonmetal. So you can see bromine has 8 around it. You don't see any around the silver because they are in the lower level. They're not displaying the valence shell. Metals don't display the valence shell. Only the nonmetals do. When we saw that with water, it was displaying its helium valence shell. Remember that? So make note of that. You'll see that again next semester. And 44. Carlos?
What's the wavelength from an electromagnetic wave that travels at 3 times 10 to the 8 and then has a frequency of 16 MHz, and I put a B?
45. Diana?
Which is the frequency of the electron? How many waves per second?
And 46. Let's go with Kaya.
What are quanta of light called? And I said D.
And 47. Let's go with Harrison.
What number was it? 47?
47.
According to the alpha rule, I got C.
47 is D. Okay, Jimmy did a nice job attempting the electron dot structure for water. Okay. 7 electrons around it. Right? And silver can have 1 to 3. In the lab, it only had 1. So the bond is right here. Now bromine now has 8 around it, which is its goal, to get 8, a noble gas.
Target points for attempting.
Structure, yes. Oxygen has 6, Jimmy, very good. So we have, right here, oxygen has 6 valence electrons. Now how many valence electrons does hydrogen have?
1.
It has 1, very good. So you find it in the first group, and you'll see hydrogen right here with 1 around it. Now I did it in different colors so you can see that it's kind of color coordinated. Now water has this bent structure. It's around 107 degrees. 107 degrees. And why is it bent? What's making it bent? These paired electrons right here. They call them they're not radicals. I think they're called lone pair because they're not bonded with anything. Lone pair, and the lone pair are actually pushing the hydrogens away. So you can see how it kind of pushes them together instead of being farther apart. Pushes them together in this bent structure. Now, last thing on this, the bent structure is what, right? So if you see electrons right here, Cameron, if you see electrons right here, what charge do you think is going to be predominantly in this area? Josh, if you see electrons right here, what charge do you think is going to be predominantly in that area? No, negative. Electrons are negative, right? Electrons are negative, so this area is going to be negative. Now, hydrogen is losing its electron to water. So what area, what charge do you think is going to be here? Positive, right? If you don't know anything, magnets are positive and negative. You didn't know that? Like this magnet right here has an area of positive and an area of negative. That's why the colors are different. So you can see that right here. Water's magnetic. It's not wet. Y'all be thinking water's wet. Water's not wet. It is it's polar and it's
Why is this
dirty? Water is wet.
Why is it a thing? Why do people have to take stupid concepts and make them into a debate? Why is this world like that? Why does it matter if water is wet?
okay. All right, hold on.
That the reason why it's a debate is because people have to try to prove they're smarter over stupid topics.
Okay. But I want you to remember, water is magnetic. It's polar, and that's why it sticks to things. When it sticks to your clothes, it's got this polar nature. No, you think it's wet because it's sticking to you. If you're driving down the road and it's raining, and somebody, let's say, has a leak in their engine and it's leaking oil on the road, the water and the oil are going to repel. So when you go over that and your car starts to slide, That's the reason oil and water repel. Right, they say if you're frying a turkey, don't put it in there frozen because it can like flash out of the container and seriously burn you, catch your house on fire. Yeah. James?
Who arranged the elements according to the continents and use the arrangement to take the I put it
31. Alyssa?
Okay. Which is the correct number of electrons in that element? I put C.
32. All right, George.
Which is the correct electron dot structure for an element fluorine? I put B.
And 33. Aaliyah?
Which region contains elements with 2 valence electrons? And I put A, and apparently that was right.
34. About Josh?
Which region contains elements with an electron configuration that ends with P3? I put C.
That is correct. Electrons. 2 lone pair electrons right here. 5 points if you can tell me what's that going to do for water. All right, Ethan.
Make it dense.
Close.
Make it liquid.
It's going to make it charged. What type of charge? Raise your hand. 5 points. Ethan?
Positive.
No.
Negative.
Negative. Electrons are negative. Everybody clear?
Oh, I knew that.
See how electrons are negative? So if there's a lot of electron here, it's going to be negative there. Now the hydrogen is kind of sharing its electrons with helium. I mean, it creates this helium structure, noble gas structure. Hydrogen has that, but they're really more closer to the oxygen. It has a stronger electronegativity, a stronger desire. So because they're farther away, hydrogen develops a positive charge. And this is why water appears to be, Ethan, this is why water appears to be wet. It sticks to things. No, it sticks to things. It's kind of like a magnet, like you see these magnets. Well, it's sticking to you. Now, let's say that Rachel is driving down the road. And let's say that she goes down a country road where some old country boy went off-roading in his vehicle and his engine got nicked and it's leaking oil. So this country boy's got a truck leaking oil and it's raining and you're driving behind him. What's going to happen when your wheels hit the oil on the road with the water? You're going to slip. Why? You're going to, oil and water do not what? Mix. So you're going to slip right off the road. So today, cars are a lot safer. If you went back like 30 years, Ethan, 30 years ago, cars were a lot less safer because they leaked oil. And that was very dangerous when it rained because cars would be sliding all over the road. Accidents, major problem. Yeah, if you look at the gaskets, like I can remember when I was younger driving down the road, and you could see the oil slick down the middle of the highway. Now you don't see that very much anymore. Very few cars leak oil. But very few cars leak oil. Well, gaskets leak. Some people, if you overfill your oil, then most people don't change their oil now. Back in the days, people did. Like if you went back 20 years, the people would change their oil. It's dangerous. If you put too much in, the gaskets can swell and then they start leaking oil. That's a problem. All right, Josh.
Okay, which of the following electron configurations of outer sublevels is most stable? It's for 14. The answer is A.
A is correct. John?
What is the electron configuration of
C.
16. Giovanni?
How does the energy of an electron change when the electron moves closer to the nucleus? And I said D, which is it decreases.
17. Let's go with Koenig.
What element has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p2? I
and I put the answer is C.
18. Record the points there. All right, Noah.
What is the number of electrons in the outermost energy level of an oxygen atom? C.
19. Giovanni.
What is the maximum number of orbitals in the P sublevel? And I said B, which is 3.
I got
20. All right, I'm gonna get Courtney. She had no one.
Okay. Which region contains the alpha and earth metals in the element B?
And 21. Tamia.
Which region contains the highest family of elements in its C?
22. Noah.
So what category of elements does an element belong to if it is a poor conductor of electricity? C.
And 23. Let's go with Trey.
Which electron configuration of the 4F energy level is the most stable? Wait, you said 23?
Yeah.
D.
And 24. Let's go with Josh.
Okay. What is the next atomic orbital in the series 1s, 2s, 2p, 3s, 3p, 4s? And for 24, the answer is B.
And 25. Noah.
It's not yours.
Which label identifies the wavelength of the wave shown? A.
26. John.
Which label identifies the the wave shown?
32 is correct.
So 32 is correct and 31 is wrong.
Because it has a measurement. Yeah.
You're close. The question is, when do you know you're going to have to use significant figures?
When you're given a measure.
Yeah, when you have a unit. The unit says, Rachel, write this down. The unit says you've taken, Rachel, I'm trying to help you pass, but you gotta listen. The unit says you've taken a measurement, like this paperclip box. There are 100 in there. 100 pieces. If you look right next to the number, there's a unit there. It says PCS. The unit is pieces. There's 100 paper clips. PCS, I think, is paper clips. But the point here is that you've got to round this to 10.6. This is correct. If you don't round it, it's wrong. This is correct because there's no unit. So when you see on the ACT, if you see a unit, you've got to abide by the rules for significant figures. And the rule is, when you add and subtract, the number past the decimal must be shown in the answer. Now let's look at one more. That's the reason why a lot of people don't score well on the ACT. They're taught this in kindergarten and they continue with it. Because in kindergarten they never have a unit on a number. When you're multiplying, when you put the unit in there, you must follow the rules for significant figures. So you have to round this to 1. There's no decimal there. So one true number would be right here. And that's the correct answer.
We're on what? 6?
6.
I said B.
6 is B. Number 7, Diego. Smile at the camera. All right, go ahead, George.
Which diagram shows that have a wave with the highest frequency? D.
That is correct. Number 8. All right, go ahead.